Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, December 27, 2021, Monday, 3:54 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया title of talk is Civil Field Engineering Life Engineers Concrete Specifications, Contracts, Designs, Construction, etc., as usual. This is my name, you can see on screen. Usually says, this is my email ID, suraj_engineer@yahoo.co.uk. If you wish, you can write to me through this phone, through this mail. Phone is also available, but I won't like to receive calls because phone is not very good medium. Your question can be composed and sent to eer@yahoo.co.uk. This is my board of address and name, you can see, and then you go to certificate that I have been issued by Institution of Engineers India on behalf of International Professional Engineers Agreement, which is an international agreement per international rules, and previously it was Engineers Mobility Forum. This certification is applicable for all members of this body, which is named as IPEA. IPEA has at present about 15 advanced nations membership like USA, England, Canada, Japan, China, South Korea, etc., and Bharat, India is one of them. This is Chartered Engineer Certificate, which is automatically, you can say, subscribed by every corporate member of Institution of Engineers India, and corporate membership means AMIE, MIE, and FIE. Whoever are corporate members of Institution of Engineers India, each person is legally authorized to use this title, Chartered Engineer India, and every engineer who is a corporate member of Institution of Engineers India is attached to one of various engineering divisions, and I am attached to Civil Engineering Division, and because I am corporate member fellow now, in 1981 I was granted associate member, then in 1986 I was granted member, and now in 2016 I applied for fellow, though I could apply before also, but I did not apply. Well, and I am having this FI title now, and of course additional certification of professional engineer. I was elected professional engineer in 1995 when institution started certification of professional engineers based on achievement in career, post at least 15 years experience that time, and now it is according to international practice, it is international professional engineer, that is minimum qualification is degree in engineering, and also at least you can say 7 years minimum, and when you say 7 years minimum means it's not less than 10 years, you can say, experience in profession of engineering, and out of that 2 years professional experience should be in high level of responsibility, and then you can say you have to submit your career report means what did you achieve in your life, what did you learn during your career, and what did you teach others during that career. And every 5 years this is renewed. If you are not very active in profession, or if you have not achieved certain levels, and of which marking is done. Marking is done out of 500 marks. You have to achieve in 5 years minimum 250 hours marks, 250 learning hours, that is minimum, and based on which your examination is conducted. Examination in first place, when you apply for international professional engineer, you have to appear in two examinations, two papers online, and once you qualify these two papers, you are allowed to appear in mandatory interview, and after interview is conducted successfully, then your case is considered for grant of international professional engineer status or title, and which remains valid for 5 years, and again you have to apply for renewal every 5 years. This is general procedure, or you can say this is type of quality issue in status of engineers. So if you want to see quality people, then you have to consider like this. I'm not saying this is guaranteed, but procedure is like that in our country, and that is first to be degree engineer or BE, or you can say AMIE or BSc engineering from here or from whatever part of world which is recognized by institution of engineers of this country for purpose of corporate membership. And once you are a corporate member, then you can entitle yourself as Chartered Engineer India Bharat with either of membership AMIE, MIE or FIE. And if you want to apply for professional engineer designation, then you must have at least 5 years experience in field of engineering, profession of engineering, and you have to submit your CPD, which is called Continuous Professional Development, and that CPD is considered by related body of institution, that is, you can say, Professional Engineers Committee, and if they think that you have adequate experience, adequate knowledge, then they can grant you PE certification. But for international PE certification, if you are found eligible for that with 7 years of experience, including 2 years in higher position, and reliability of your CPD, that you can achieve 250 marks out of 500, then you are asked to appear in examination, 2 papers, and after qualifying those 2 papers, first you have to qualify paper 1 and then to qualify paper 2, and these have nothing to do with engineering syllabus. These are different world. This is practical world of quality, world of safety, world of engineering, world of society, world of law. Likewise, there are so many extra or extended portions of engineering which are applicable in profession of engineering. And once you qualify those 2 parts, 2 papers, you are asked to appear in online interview or video conferencing, and when you qualify that one, after that it is recommended to board of certification, and then board of certification approves your international professional engineer membership, or you can say certificate, or you can say title according to IPEA, and this register is maintained by Institution of Engineers India on behalf of IPEA. IPEA means International Professional Engineers Agreement. India is represented by Institution of Engineers India, which is a chartered body according to Royal Charter 1935. This is the background of this. I just wanted to explain this so that people know about this. Now I come back to quality in Bharat, India. That's a very important point. I close this certificate of chartered engineer and also close certificate of FI, and open a file of concrete specifications which I have to speak about. And before that, I just give something about quality, because quality is something that we have to worry about. It's not that right, thinking that automatically it shall work. To keep that in mind. Nothing works automatically. We have to think of that. We have to be very clear about this, that nothing happens automatically and we have to struggle. And quality in Bharat, India, I'm talking because I have worked in many countries. I started from Iraq, then I started in Iraq and worked in projects, buildings in Baghdad, in Sharqat, Mosul, and also I worked in Libya, in sometimes in Benghazi and sometimes in Tripoli, and you can say sometime in, you can say worked in, you can say, what do you call it, there was some project in remote area in what do you call it, in Libya desert there was a project of power station, diesel power station. I worked there, and also Sirth town. It was Sirth town, Sirt. So I worked in many locations. You can say Sirth, Benghazi, Baghdad, Tripoli, in Libya, and then I also worked in Qatar, Doha. I worked in Doha, proper Doha, Amsalal, Dukhan, and also I worked in, you can say, Amsaid or Al Khor. Same way I worked in Abu Dhabi, Ruwais, and you can say Mahmoudia, or you say what you call it, you can say original Abu Dhabi, near town, industrial town, Musaffa, and I worked in also sometimes in Saudi Arab. So likewise, you can say sometimes I worked for Chinese company, also worked in India as consultant, but not very successful consultant, because in our country, consultant means they're not valued excessively, or they're not valued adequately, you can say. Quality in Bharat, India has dropped because professionals are not valued. Professionals are not valued in this country. It's unfortunate. I'm not giving bad name for ourselves, I'm not giving, but quality in Bharat, India, because first of all, I can't blame government also, because government is not engineer. They do not know what engineers are, and those who in governments, those engineers employed by government, I keep them aside while talking engineering, except those who are in very high scientific areas. Other than those who are in scientific areas, I can say all others are not to that level, even if it is CPWD or it is some other department, government department. It's actually constructive criticism, I'm saying, means they are bound by their own specifications, obsolete specifications, or you can say they don't have that authority that engineers should enjoy, like independent engineers or practicing engineers. They are just owned by their own system. So I can't expect, and they should not also expect, they can do something in quality world, because it's not only alone that civil engineering requires quality, it is every discipline in engineering, every branch in engineering where quality has been affected adversely. And it's open fact in engineer world, in engineering world, Bharat, India has suffered a lot. It started good in beginning, but due to interruptions by, you can say, business people, interruptions by commercial people, interruptions by political people, quality has been impacted badly. It's not very extraordinary news if you hear someday the building collapsed there, or during construction something happened, shuttering opened, or you can say this bridge was constructed and it fell. Such news are very often seen and heard in our country. And I'm not saying that in our country alone. There are many more news as such news which are heard from many other parts of world, but not that often. In our country, it's something you cannot say if such news comes, people are very serious. No, nobody becomes serious because seriousness is not our metric, you can say, property. Seriousness cannot be defined in Bharat, India. One should be serious or one should not be serious. There is no silver lining defined. I can't see anything that if you remain from this line, you are serious, or if you cross this line, you are not serious. There is no existence of any definition as such. Sometimes you are serious, you don't care, and sometimes you are not serious and you don't care. So seriousness means, I don't mean your face should be serious. I mean, state of mind should be serious, that's what I mean. And seriousness is something that should be evaluated. Seriousness means, it doesn't mean if you're laughing you can't be serious, it's not that. If I laugh, I smile, and it doesn't matter. It doesn't mean I'm not serious. It's like that when you land somewhere, for example, you land at Heathrow Airport, you have to apply for visa there or you have to get entry. There will be questions or interrogations by immigration officer. And that person will smile, show you some teeth. You think, oh, this person is very nice. But it's style. It's not that because that person smiles shall give you favor. Not at all. That's what I'm saying. Do not measure, do not evaluate what is the status according to developing phase standard at that time. If I smile, it doesn't mean I'm not serious. Or if I am very in bad phase, if I express my bad phase, it doesn't mean that I'm serious. Not at all. It is work. What way I do my work, what way I take it. I use my concentration on work or I just ignore that. If I supervise some activity, I have to be with that activity fully. That is called seriousness. If I don't care, okay, let somebody tell somebody, okay, you take care. This I leave it to other because I am very busy. Okay, you are busy, but other person should also be like you. Maybe not in your educational qualification, but for that activity, that person must be same level attentive as you are. That's okay. But what happens? There is an attitude development in our country, no problem. Sometimes we used to say 1920 means, okay, it is 1920, 19/20. What do you mean by that, Okay, it is okay, no problem, it should be 20, but it is 19. Means there is some difference in work, no problem, it would do. That approach is very harmful. It can be 1920, it can be 1020 also, or it can be 520 also. What to do in that case? Quality has been spoiled by our people, ourselves. What do we think? If something is accepted, it's okay, fine. In our construction world, always there remains conditions that even if consultant or engineer who is authority to approve or reject some item, that is accepted by engineer means it is finally done. This is what we think so. But contract does not think so. Contract conditions clearly mention, it's not only in our country, I'm not sure about our country, but in every other country, and also in FIDIC, which is standard format of contract. Conditions are very clear that it is contractor who remains responsible for activity or work for which contractor is paid. Even if that item is accepted by engineer or resident engineer or supervising consultant, it doesn't mean that that is finally accepted, because acceptance criteria lies with contractor or person who does that item. That person or contractor is responsible for that item because that person or contractor is expected to be expert of that item, expert of carrying out that item, and moreover, that person is paid for that. So that person who receives payment for some item should be responsible for that item, and that's natural. Even I approve as engineer, okay, you have done right, fine, I certify. That certificate does not mean that quality has been achieved. It is only assumption that engineer certified it. Engineer must have inspected that properly, but that item was done, is done, or has been done by that contractor, and that contractor is responsible for that. That is basis of contract and supervision. It is responsibility, accountability of contractor because you are paid, and you cannot shed away your responsibility. You are responsible 100% because you did that job. That consultant or supervisor only supervised that or inspected that and approved. That is what I say. I'm not blaming here someone, and not to blame anybody. Even contractor should not be blamed, because contractor is contractor. Contractor employs engineer on job. They are paid. It is job of that engineer until contractor least interferes. As far as engineering work is concerned, the contractor does not have the right to interfere because of greed, because of avarice, because of saving money, or because of whatever reason. That engineer remains under pressure and wants to move job too fast, rapidly, and where you can say ratio proportion between quantity and quality lapses. We sometimes say quality lags behind quantity. We say what should be quality and quantity move together, we should say, but it doesn't happen. Then we say, where is quality? भारत इंडिया में गुणवत्ता किधर है? गुणवत्ता कहाँ बैठती है? Where does exist quality? In India, Bharat. Where is it located? I don't find any seriousness among engineers about quality delivery. Statements are fine, certificates are fine, that work has been done according to such specifications. Certification is fine, but reality is not fine. If you just certify, I have supervised this, and this work has been done according to specifications, you will find such certificates in lakhs and lakhs numbers. Every work is certified as such. But when you investigate, you shall find differences. And I don't see any material in market, any product in market that can someone confirm that this is according to quality compliance. Because it doesn't work that way. It doesn't work that way. I don't know what reason other than lack of supervision or lack of controls. I can't find any other reason because of this lapse. And can there be some other reason? You tell me. If you are using material, you are spending money on that material, and even then you don't get quality material, what does it mean? It may be whatever material, whatever good you can say, spare part or machine or equipment or construction, everywhere there is a dictate of loss of quality, or you can say carelessness attitude of towards quality, and that is, you can say, a lapse on part of engineering and engineering activities and therefore engineers. No employer shall like to destroy material, but I don't know reason for that. They get some benefit or not out of that, only they can answer. I have no such clue about that. I understand English I am speaking, it means that I want to share this information with people, particularly in our country. Hindi is used in many parts of this country, say 60-70 percent parts, but English or Hindi doesn't make a difference if you think in a qualitative way. It says quality certification is not important because it is not issued because of factual quality existence, but it has become a kind of common practice, general practice, that you must have a certificate, for example, ISO 9001 2015 certification, and people get this, and I don't know how they get this. Either those people who issue certificates as such, they may not be having that caliber, you may say, or there is some other way they get it or they issue this. But fact remains that quality falls because we have government institutions, state institutions, private institutions, and no quality exists anywhere. No thought is given to that. The system is defined, every work is defined. Even government institutions have been certified quality compliant, but working doesn't prove that they are quality compliant. There has been a display of seminars, you can say online conferences, online webinars. So much is ongoing, you can see these days. During this COVID period, so much has been going on that you do not know which seminar or which webinar, which day, what time. And I don't think there's any specific benefit of that. We are not able to train people as they should be. If one subject is there, other subject is there in the same seminar, and just 10 minutes, 15 minutes are given to one person. Well, it is different way. I'm not going to that. It's up to professionals how they handle. But ultimately, what should be important point here is, when I buy product, it should be quality oriented. That should be objective of our requirement. That should be objective of quality. Product for which I pay, I should get back that product in that level. But I expect added quality also, added value also to that. Forget added value. If I don't get basic value, how can I expect added value onto that? Therefore, I am keeping both on same stage, government institution and private bodies. They both are responsible for dropping quality. Drop in quality in system, in working of institutions, in working of, you can say, government bodies, in working of private bodies, in working of even you can say statutory bodies. There has been drop everywhere. No quality system exists, but certificate is always available. This is ISO 9001 compliant. There's no such response. You have to suffer in every office. You won't get anything done in time. And you can say, no one is worried about anything, but your certificate shall be renewed after requirement period is over, after use period is over. Okay, I am interested in products. I spend money for buying something. If I don't get that product according to my requirement, then for me that product is defective, that product is having demerits. And it's very difficult to deal with that situation in that environment because again quality binds them and binds you, and you have to suffer on account of that. I'm not saying everyone is bad, but when you see generality is bad, when you see majority is bad, we can say everyone is bad, though in particular everyone cannot be bad. We have to move forward. We have to move forward, our country, our society, our nation, and we have to move with world. There's no doubt in that. But if we have to move with world, we have to make ourselves like world. And what doesn't mean they are all right. We can be leader, but we are not even followers. How can we be leaders? I am not referring to political statements because I don't believe in those statements. It's not only our political statements, it can be from all other countries' political statements. Political statements won't give us anything. That's a true fact. No political statement is valued by me or by professional engineers because we know this is politician. This is politician statement. It doesn't mean anything. It doesn't mean anything, but in engineering, statement doesn't work. If you say statement, it doesn't work. If you say method statement, then it's meaningful. We cannot use alone statement. Our statements are titled. They have certain nomination. Like you can say method statement, claims statement, or you can say billing statement. Something stated means it should be detailed. It's not a paragraph. It's not only title. It should have complete rationalization. Only then it can be said fine. Politics is different, and engineering and politics are other fields, opposing fields, because politics means selling of lips, lip service, vision, sale of vision, sale of dreams. But in engineering, dreams are not sold, dreams are created. That's the difference. In civil engineering, that includes architectural engineering, dreams are viewed and those dreams are created. And when something is created, naturally it shall be sold. And that's what engineering is. In politics, just speak anything. Speak whatever you want to please people with. And your business is how to get democratically votes. That's all. Once you get votes, then all you forget. No need remember. That's fact. But engineering is not that. Engineering means you have to produce. And if you cannot produce, then how can you say, I have done it? If I imagine a building as civil engineer or a building structure, I can successfully imagine because I know engineering, I know designs, I know how to do something, I know how structure can be done. This is my basics. If I don't know that, I'm not qualified engineer, but I'm not expert as well. Okay, fine, but I know how it can be done. How can it be done that I know? I don't care for something else. I know theory. I know how it can be converted from theory state to practical state. And that's where I see it's very important point. If I can convert it, if somebody finances it, then I can say this is practical structure, this is physical structure. So we have changed or transformed that dream structure through our work of design to physical structure through execution of that job. Otherwise, it remains in mind only without any concrete results. And that's what I say is seriousness. We can transfer imagination or dreams into physical being. And that is what is responsibility. It is called worry, technical worry, intellectualism. It is called intellectual work from imagination, from dream world to physical entity formation. And this is what is engineering. Engineering says think, 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 and create, create, create. You have to think and you have to create. And this is difference in other professions and in engineering. All other professions are based on other professions, but engineering is not based on other professions. Engineering is based on engineering only. Civil engineering is based on mechanical engineering or the electrical engineering on many other engineering. Same way, mechanical and electrical engineering are based on civil engineering and many other engineering. This is mutual interactive profession. No civil engineer is alone today. No civil engineering project is independent today. Likewise, no electrical, no mechanical or others are independent today. Interactivism is very viable, and without that interactivism, we cannot move forward. We cannot provide electrical supply. We cannot provide mechanical supply to structures, to buildings. Same way, if there is no building, no factory can be established, no industries can be established. Likewise, you can say engineering is a multidisciplinary world. Though everybody is educated in certain branch of engineering, that is from education point of view, but not from work point of view. Education is acceptable, that's fine. I say, for example, I am civil engineering qualified. It doesn't mean I do not know anything else. During civil engineering syllabus, I studied mechanical engineering, electrical engineering, of course, very elementarily. You can say 2% to 5%, not 100%. I got that knowledge only so that when I deal with that, I should not find that this is a different word for me. Means it's some practical aspect, and when we work on projects, we have to deal with all kinds of works, all kinds of other discipline works. It's not concrete alone or cement, mortar or brick alone. We have to deal with other services as well. If you are in charge of that project, dealing with electrical world, dealing with mechanical HVAC machines world or equipment world. Likewise, now it is IT world. So we have to deal with those terms, those conditions, those drawings. Identification of drawings are very important, so we should not be surprised on that. Oh, I never knew this, how this is, what is HVAC. You should know what is that, and you have studied that at least. I studied for that even thermodynamics, I studied even non-engineering subjects like worker relations, though this cannot be said non-engineering, but you have to study civics as well sometimes, social science, sociology. Likewise, you can say many inputs must be with every engineer. If we cannot do that, it is engineer who is called social change agent. We used to call before, many times I have repeated this, engineer is a social changer. If you want to change society for better, it is only engineer who can do that. But engineer alone cannot do that because it's human. Resources are required, and that resources is finances and other resources like trained human resources, trained equipment, so you can say customized equipments. Only then it can be possible. Now, everything is possible, let us say. All resources are possible. Will is also possible. But if understanding of quality, or even if quality standards are available, implementation of standards are necessary. Which requirement we have broken? Which requirement? Just like in other products, non-civil engineering products, same way we have broken our products. And that is where problem lies in. And I actually don't understand why quality has been falling. Other than this, the people are careless, and that's all. But engineering cannot move by carelessness. Engineering has to move with full care. Full care requires in engineering, otherwise, we cannot do engineering. That's why I try to concentrate on very important material in engineering and particularly in civil engineering. It is concrete. Concrete name itself is grammatical or dictionary wise. If you say concrete, this means something very solid, something very strong, something very, you can say, everywhere used in your work of engineering, and it's meant for all. This product cannot be classified as for objective only for some. You cannot run away from concrete even if you want to run away. Even if you are not engineer, you have to deal with this product for every activity. And therefore, people know what is concrete. Of course, name can be different. Those people who do not know engineering or do not understand concrete, they may say, okay, this is lantern in our country, or this is lantern. Sometimes when they say road is lantern, there's a word lantern we use in north. I don't know what's in south of this country, but in north part, particularly in Delhi around, concrete is named by people, oh, this is lantern, masala lantern, they speak like that. But well, this public, you cannot change, you can't force people to watch concrete, they don't understand sometimes, Lantern, they don't say slab, they don't say column beam, pillar they call it, column is pillar, and likewise, no problem as far as name is concerned, I don't think there's a big issue. But the question is even, but that should be called, you may call lantern, you may call pillar, whatever you call it, it's your choice. But concrete should be quality oriented. That's what my intention is. Name doesn't make any difference if you deliver good product. I'm not going to criticize about what's happening in politics because I'm not politician first of all. I am engineer and I'm not manager and I'm not scientist, but I have to think of development. And if we have quality, we can maintain quality, then we can move in international level. If our products are quality one, it may be civil engineering product or others, we can sell our products in international competitive market. And if we depend on their products, we have to import products from every other country, then how can we develop engineering? That's first requirement. And I don't think that there is any dearth of engineers in our country. There is no shortage. Abundance of engineering professionals are available. But if quality is not available, then there is no meaning of these professionals, quantum. You may be millions, it doesn't make a difference because you are not used to quality and quality is not used by you. I've seen people not interested in quality, not interested in field work. They are interested in work where computer is involved. Generally, it happens as many degrees you achieve, you obtain bachelor, master's, doctorate, you keep off from practical world. That has been seen. But this is not correct approach. Those who have higher education like PhD or masters, they think that they have gone beyond field work. And that is where weakness lies. That is where difference lies. They don't keep in view that it is field work only. That is approach. That is final objective of engineering. Final objective of designs and research. If your field work is not achieved to levels of quality, required levels of quality, where does engineering lie? Engineering doesn't lie in university teaching. Okay, teachers are required there, professional teachers. But that is professional teacher only. That is not a professional achiever. Teacher cannot be called achiever. Yes, it's a route to achievement because teacher makes a good which is known as a student into academic based professional. That student knows theory and very ignorable limited practical work. If you talk to some or interview some professional teacher or professor can answer you all degree questions, all theoretical questions, but when it comes to question of practical work in field, I will be disappointed. Believe me, I will be disappointed because at that point professional stops. Professor cannot move further. Even if that professor conducts some research or some design work or some consultancy work, because consultancy and design are rendered meaningless if these are not based on practical experience. It's a fact in engineering. When you are in field, you do practical experience, you find realities. You find, oh, I did not study this. Nobody told me this can happen. That stage is a void, is a blank. This blank requires to be filled. And that's where our education system becomes defective because our professional teachers or professors are not field oriented. They are only academics oriented. They can transfer academics to students, but they cannot transfer physical work to students. They can't tell them what is right, what should be done, what is efficiency, what is quality, because these teachers have never been exposed to efficiency and quality. And it's not a criticism of teaching, because our system is that. I have not seen any professor or teacher who can claim I worked for 15 years or 10 years in field of engineering and I am teaching this to my students, because hands are bound by syllabus. And syllabus is only theoretical, and theory cannot be used 100% in field. And okay, even if it is used, where is practical work? There is a requirement of both theory and practical work in profession of engineering. When we say profession in engineering, this means work in engineering. Work means theory plus practical. If somebody knows theory and that person doesn't know how to apply it in field, how to execute in field through designs and construction, that person cannot be called professional engineer. Professional engineer demands that you should know first of all theory, and you know how to successfully apply that theory. And if you know that successfully application, then you can say you are real engineer. You are not imaginary or hypothetical or skeptical engineer, but engineer who knows how to do this work. And when you know how to do this work means you have exposed yourself to physical work where all kinds of site related problems you have experienced, and that's very important part. And that's what we can say. Your attitude changes at that time you work in field. You know facts. You know facts that when excavation is done, it's not exactly line, but when you drawing, you will give straight line. That's only difference. And it's big difference. You know how work is done inside, what problems are faced, how you have to arrange material, workers, equipment, and you have to collaborate with all. You have to coordinate with all one by one, and that work, all activities or all resources that you want to employ for that activity must work together time wise and activity wise. Otherwise, you cannot complete any work. So you can waste time even if you do not know how to use these resources. And that's where I say, whatever way there is a lapse, there is a problem, ultimately quality would suffer. And that's why I say engineering coordination is very important. I always for people to irritate them, that you can say no seriousness has been observed among engineers from all branches about quality requirement with no known reason. No material in market is available that can give quality performance. Yet quality mark is owned by material manufacturer. How is it possible? This means that quality certificate is not perfect. Whether or not private or government, quality exists nowhere, but in lip service only or in publicity, just to deceive purchaser. Sure, the engineers have forgotten quality, or they did not study about what does quality mean. Government least bothers because it doesn't care for engineering and engineering products. Companies least bothers because they are commerce and business oriented and believe in shortcut earning methods. No long-term vision. Professional engineers never ever bother because they have gotten no independent standing and are unable to fight against abuse of quality system and tacitly support misleading publicity. Engineers are not well trained to an extent quality is concerned because quality cannot be learned in theory alone and computers use cannot bring quality input into products. Thousands designers and executives are available but never deliberate quality reasons are unknown. Is this what we call engineering and call engineering failure really concrete now? Already enough time has been given to generality. Now come back to our system of protective coating we studied last time, and now I'll say let's start from protective coating. So it can be done further also. A coating system shall be used for protection of new or existing reinforced concrete structures against carbonation or chloride induced corrosion. System shall comprise of a penetrating reactive primer and an acrylic polymer top coat system to minimize ingress of acidic gases, chlorides, and water. Says system system shall comprise of penetrating reactive primer and an acrylic polymer top coat system to minimize ingress of acidic gases, chlorides, and water. And in surface preparation, before application, all surfaces must be dry and free from oil, grease, loose particles, decayed matter, moss or algae, growth and general curing compounds. All such contamination and latents must be removed by use of grid blasting. All surfaces which are not to be coated but which may be affected by application of coating shall be fully masked, and in particular flora and fauna shall be protected. Blowholes and areas of pitting shall be made good. Blowholes and areas of pitting shall be made good with one part modified cementitious material and allowed to cure in accordance with manufacturer's recommendations. In particular, application shall be conducted in accordance with manufacturer's recommendations. Materials are required to provide in-depth protection against carbonation and chloride penetration, whilst permitting water vapor transmission from concrete. Primer shall be a low viscosity silane siloxane system which penetrates deeply into porous substrate and reacts to produce a bonded hydrophobic lining to pores. Materials employed for coating shall comply with following requirements. Wet film thickness is 400 micrometer. Wet film thickness WFT 400 micrometer, 400 into 10 to power minus 6 meter. So 0.00004 can say meter. Dry film thickness is 200 micrometer. Carbon dioxide diffusion resistance is R value 325 microns, greater than 161 meters. Carbon dioxide diffusion resistance it is. This is from Taiwood Engineering Laboratories, R value at 325 microns, 161 meters. And what's R value? Let's see. Carbon dioxide diffusion resistance. We should see this also. Carbon dioxide diffusion resistance. Let us see what is that, because sometimes we have to go interactively. This is called theoretical coordination, and R value, and it says that it should be carbon dioxide diffusion resistance. Let me see how it works. Carbon dioxide, let us say carbon dioxide diffusion resistance. Carbon dioxide faces a series of resistances while diffusing between substomatal cavities and sites of carboxylation with chloroplasts. Resistance to diffusion through intercellular space differs between leaves, but is usually of minor importance. Says resistance along carbon dioxide diffusion pathway inside leaves, resistance to carbon dioxide diffusion culture circle mirrors, and we have to see our point is resistance. It says carbon dioxide diffusion resistance. Carbon dioxide diffusion resistance is that one. It says resistance to carbon diffusion. PDF resistance along with carbon dioxide diffusion pathway. Let us see what it says. Something so that we can know what we are talking of. That's very important. And it's not, you can say, download full text file. Let us say for carbon dioxide faces a series of resistances while diffusing between substomatal cavities. If I can download this file, you can also show. You can download full text PDF file. Let us say it's that I'm trying to download this file, so you can also say, oh my god, they join for free at this and that. That's problem with these people. Every time they give advertisements and you have to follow that. So I go back. I don't want to go into that. So let us say what it says. This problem with this. Let me read what it is so that you can know. It says carbon dioxide faces a series of resistances while diffusing between substomatal cavities and sites of carboxylation within chloroplasts. Absence of techniques to measure resistance of individual steps makes it difficult to define their relative importance. Resistance to diffusion through intercellular aerospace differs between leaves, but is usually of minor importance. Leaves with high photosynthetic capacity per unit leaf area reduce mesophile resistance by increasing surface area of chloroplast exposed to intercellular aerospace per unit leaf area. Cell walls impose a significant resistance, assuming an effective porosity of cell wall to 0.1 or 0.05, then cell wall could account for 25% to or 50% of total mesophile resistance, respectively. Since fraction of apolastic water is bound, unbound, and available for unhindered carbon dioxide diffusion is unknown, it's possible that it's possible that effective porosity is less than 0.05. Effective porosity could also vary in response to changes in pH or cation concentration. Consequently, cell walls could account for greater than 50%, more than 50% total resistance, and a variable proportion. Most remaining resistance is imposed by one or more three membranes, as mesophile resistance can be altered by varying expression of cooperants. Carbon dioxide permeability of vesicles prepared from chloroplast envelope has been reduced by RNA interference, RNA expression of anti-AQP1, but those prepared from plasma membrane. Carbonic anhydride activity anhydrase activity also influences mesophile resistance. Mesophile resistance is relatively insensitive to manipulation of step in pathway because it represents only part of total and may also be counteracted by pleiotropic compensatory changes. So that's something about this. It's not exactly what we talk of, but let us, because some information is a must. So that's carbon dioxide diffusion resistance is average 325 micron to get 161 meters, and water vapor transmission. It's also from Taiwood Engineering Laboratories, shall be more than 13 gram per square meter D. That is water vapor transmission. Reduction in chloride ion penetration. That is BS 1881 part 124. Reduction in chloride ion penetration 94% minimum at 28 days. Now, tear resistance ASTM D624, that is 7.3 kilonewton per millimeter square. Tear resistance and crack bridging, a BRE method, 5.1 mm. Chloride on diffusion, Taiwood Engineering Laboratory, 3. For coating shall comply with following requirement, and I repeat, wet film thickness 400 micron. Generally, this is used in painting, etc. Also, film thickness, wet film thickness, and dry film thickness. Wet film thickness is represented by WFT, and dry film thickness is DFT. So dry film thickness is 200 micron after wet film thickness is 400 microns. So there is a reduction in that. Therefore, carbon dioxide diffusion resistance is R value 325 microns, and water vapor transmissions shall be more than 13 gram per meter square. Reduction in chloride ion penetration is 94% minimum at 28 day, because this membrane shall not allow chloride penetration once coating is done. So that's where 94% reduction is. Only 6% penetration is permissible in this case, and which is of course not that detrimental for you can say long-term requirement or long-term meeting. And tear resistance is at 7.3 kilonewton per meter square, and crack bridging is 5.1 mm. Chloride ion diffusion is 3.63 in 10 to the power minus 10. So you can say 10 to the power minus 10 means 1 over 363. You can say 3 into 63 divided by 10 0, 1 and 10 0. Specified procedure for establishing compliance with above criteria shall be agreed with the engineer. Where test methods are not specified, how to do that shall be discussed and finalized with the engineer. And we can then about contractor is required to adhere strictly to manufacturer's recommendations. Contractor is required to adhere strictly to manufacturer's recommendations regarding use, storage, application, and safety rules in respect of approved materials. So first of all, these properties we have discussed about this coating are very significant from technical viewpoint, from understanding viewpoint. And then we have by engineer, trial areas not exposed in finished work shall first be treated using selected materials. Using selected materials. It's 5 o'clock for me. Yeah, I can say. You can say when required by engineer, trial areas not exposed in finished work shall first be treated surfaces as defined in documents or as agreed with the engineer. Exposed concrete surfaces as defined in documents or as agreed with engineer shall be coordinated, shall be, you can say, it's not conditioned, I think, shall be, just a minute, so I'm not able to read clearly, shall be carried out, okay, and this is shall be, where is gone, just a minute please, hold on, yes, there's some documents problem here. Exposed concrete surfaces as defined in documents or as agreed with engineers shall be conditioned, yes, shall be conditioned, I was actually the projected one, shall be conditioned by application of a penetrating hydrophobic treatment, shall be conditions by application of a penetrating hydrophobic treatment. I this from page only, not from direct projection. So let's say exposed concrete surface defined in documents or as agreed with engineers shall be conditioned by application of penetrating hydrophobic treatment. Primer shall be allowed to dry in accordance with manufacturer's requirements. Contractor shall then apply 2 coats of pigmented top coat in accordance with manufacturer's instructions. Finished coating shall be pinhole free and no total mill as total minimum dry film thickness of 150 microns. Coating shall be applied by spray, roller, or brush to achieve a finish acceptable to engineer. In all operations of storage, mixing, and application, contractor shall comply with health and safety recommendations of manufacturer and governing authorities. I repeat, because this is application, where required by engineer, trial areas not exposed in finished work shall first be treated using selected materials. Trial areas shall be noted on drawings and carried out using type of materials, mixing procedures and applications that be used in contract and approved by engineer before contract commences with general work. Exposed concrete surfaces defined in documents agreed with the engineer shall be conditioned by application of penetrating hydrophobic treatment. Exposed concrete surfaces defined in documents or agreed with the engineer shall be conditioned by application of penetrating hydrophobic treatment. Primer shall be allowed to dry in accordance with manufacturer's Finished coating shall be pinhole free and have a total minimum dry thickness. Well, this is 150 will be applied by spray, roller, brush to achieve finish acceptable to engineer. In all operations of storage, mixing and application, contracts shall comply with health and safety recommendations of manufacturing governing bodies, governing authorities. Plastic sheet liner for concrete structures. Plastic sheet liner for concrete structures. Jammed, this is now. Says this subpart covers supply and installation of sheet liners in reinforced concrete structures. Sheet liners. Liner must be continuous and free from pinholes both across joints and in liner itself. Liner must be continuous, free from pinholes both across and joints and in liner itself. All work for and in connection with installation of lining in concrete, pipe and structure and held you can say sealing and welding. Let me go to real page. I am not able to read sometimes because of bad writing. Subpart covers supply and installation of sheet liners in reinforced concrete structures. Liner must be continuous and free from pinholes both across joints and in liner itself. All work for in connection with installation of lining in concrete pipe and structure and field sealing and welding of joints will be done in strict conformity with applicable specifications, instructions and recommendations of lining manufacturer. I repeat, all work for and in connection with installation of lining in concrete pipe and structures and field sealing and welding of joints shall be done in strict conformity with applicable specifications, instructions and recommendations in lining manufacturer of material certifications, test results, material samples. Manufacturers of lining shall submit an affidavit attesting to successful use of material, attesting to successful use of this material as a lining for sewer pipes and structures for minimum period of 5 years in service conditions recognized by corrosive or otherwise detrimental to concrete. Liner material requirements. Sheet liner shall be manufactured from high molecular weight PVC. Sheet liner shall be manufactured from high molecular weight PVC or PE resin. PVC is polyvinyl chloride and PE is polyethylene resin and other components necessary to make a material of permanent flexibility suitable for a liner in concrete pipes and structures in sewerage services. Weld strips and joint strips shall be made from like materials for PVC and PE sheet liners. Actual resin used in manufacture must constitute not less than 99% of resin used in formulation. Sheet liner shall be manufactured from high molecular weight PVC or PE resin and other components necessary to make a material of permanent flexibility suitable for a liner in concrete pipes and structures in sewerage service. Weld strips and joint strips shall be made from like material PVC and PE sheet liners Actual resin used in manufacture must constitute not less than 99% resin used in formulation. Copolymer resin will not be permitted. All plastic sheets, including locking extensions, all joints and welding strips, shall be free of cracks, asperities, and other defects that may affect protective properties of material. Properties of PVC and PE sheets are shown in table. We'll see that. This is table 14.2. Properties of PVC and PE sheet liners. Properties of this, you can say PVC, that is elongation at break, then it is tensile strength, and after that low temperature brittleness. According to test method, PVC, that is elongation at break, is 300%. You can read code yourself. 300% requirement, and tensile strength is, I think, 15 MPa. Let me go to page and see because it is small. So elongation at break is according to ASTM D63882 300%. Tensile strength is according to ASTM D638412 15 MPa. Low temperature brittleness is ASTM D7460 degree Celsius. Then PE, elongation at break, is exceeding 600%. PE is more, more elongated. It has elongation power. Tensile strength is 10 to 20 MPa. You can see something like same in PVC, but low temperature brittleness is minus 75. So you can say PE is in that way better. Then you can say plastic sheet liner strip properties. Plastic sheet liner strip properties except at shop welds. All plastic sheet liners and strips shall have properties shown herein when tested at 25 degrees Celsius. Tensile properties of plastic sheet liner strips, and this was plastic sheet liner strips. Tensile strength 15 MPa. Elongation at break is 200%. Shear durometer is 1s50 to 60 plus minus 5 with respect to 10 seconds. 35 to 50 plus minus 5. Weight changes plus minus 1.5%. Basic sheet dimensions. Minimum thickness of material shall be as shown below, and that is plastic sheet minimum dimensions. Material thickness, that is sheet with locking extensions, 4 mm. Sheet plane 2.3 mm. Then joint strip 1.9 mm. Weld strip 2.4 mm. This is basic sheet dimensions. Now liner details. This locking extension, which is T-shaped, shall be of same material as that of liner and shall be integrally extruded with sheet. Locking extensions shall be approximately 65 mm apart and at least 10 mm high. Sheets not used for shop fabrication into large sheet shall be shop tested for pinholes using an electrical spark tester set to 9000 volt per 1 mm thick. Thickness of lining minimum. The holes shall be repaired and installation of lining including preheating of sheets in cold weather and welding of all joints, shall be performed in accordance with recommendations of manufacturer. There's some page here, I think. If you can see it, I can show you by chance. I noted it here. I just got that downloaded. That means resistances along with carbon dioxide diffusion pathway inside leaves. It's given here. You can see blown up figure here. Resistance along with carbon dioxide diffusion pathways inside leaves. And this is Journal of Experimental Botany. It was in April 2009. And here are authors: John R. Vance, Eco Thompson, names are here. And it says, what is abstract here is, it's very, carbon dioxide faces a series of resistances. Carbon dioxide faces a series of resistances while diffusing between subtomatal cavities and sites of carboxylation. I think you have heard this. I will little keep it down. Yes, so that's clear. So I can keep it 140, 135, let us say 135. So it's okay. I think it's okay now. So carbon dioxide faces a series of resistances while diffusing between substomatal cavities and site of carboxylation. Within chloroplasts, absence of techniques to measure resistance of individual steps makes it difficult to define their relative importance. Absence of techniques to measure resistance of individual steps makes it difficult to define their relative importance. Resistance to diffusion through intercellular airspace differs between leaves, but is usually of minor importance. Leaves and high photosynthetic capacity per unit leaf area reduce mesophile resistance by increasing surface area of chloroplasts exposed to intercellular airspace per unit leaf area (SC). Cells walls impose a significant resistance. Assuming an effective porosity of cell wall of 0.1 or 0.05, then cell walls could account for 25 or 50% of total mesophile resistance, respectively, since fraction of apoplastic water that is unbound and available for unhindered carbon dioxide diffusion is unknown. It's possible that effective porosity is less than 0.05. Effective porosity could also vary in response to changes in pH or caution or cation concentration. Consequently, cell walls could account for more than 50% of total resistance and a variable proportion. Most remaining resistance is imposed by one or more of three membranes, as mesophile resistance can be altered by varying expression of cooperation, by varying expression of cooperance. Carbon dioxide permeability of vesicles prepared from chloroplast envelopes has been reduced by RNA interference. RNA interference expression at anti-AQP1 but not those prepared from plasma membrane. Carbonic anhydrase activity also influences mesophile resistance. Mesophile resistance is relatively insensitive to manipulation of step-in pathway because it represents only part of total and may also be countered by pleiotropic compensatory change. Parameters in greatest need of additional measurements or SC mesophile cell walls thickness and permeabilities of plasma membrane and chloroplast envelope. An introduction is very complicated here, so we can say consumption of carbon dioxide. Consumption of carbon dioxide by Rubisco reduces partial pressure of carbon dioxide in stroma of chlorophyll, so this is very much technical. I'm not going to that. This diagram says leaf anatomy varies between species and growth radius, so liquid phase, and I don't think this is of much use to us. I just wanted some introduction in this, and I think now now look back to installation, which is a very important part here. Installation we go back to, and that's what we say installation about, and that's, I think I'm still wrong here. Let's say Facebook here, yes, so you can say I let me close it, it's no use. Okay, installation of standard. So we say installation, and it is installation of lining including preheating of sheets in cold weather and welding of all joints shall be performed in accordance with recommendations of manufacturer. Recommendations of manufacturer is a very important point because this is a proprietary item and only manufacturer is responsible. So it's like engineering issue. It says installation of lining including preheating of sheets in cold weather and welding of all joints shall be performed in accordance with recommendations of manufacturer. Lining to be held snugly in place against inner forms by means of steel banding straps or other means recommended by manufacturer. Concrete that is to be poured against the lining shall be vibrated, spaded or compacted in careful manner to protect lining and produce a dense, homogeneous concrete, securely anchoring locking extensions into concrete. Concrete that is to be poured against lining shall be vibrated, spaded or compacted in a careful manner to protect lining and produce a dense, homogeneous concrete securely forms. In removing forms, care shall be taken to protect lining from damage. In particular, sharp instruments not to be used to pry forms from lined surface. When forms are removed, nails that remain in lining to be pulled without tearing lining and resulting holes clearly marked. Form tie holes to be marked before ties are broken off, and all areas of serious abrasion or damage and all cut, torn and seriously abraded areas in lining shall be patched in this way. Patches made entirely with welding strip to be fused to liner over entire patch area. Larger patches may consist of smooth liner sheet applied over damaged area with adhesive. All edges must be covered with welding strip fused to patch and sound lining adjoining damaged area. Hot joint compounds such as coal tar shall not be poured or applied to lining. Contractor shall take all necessary measures to prevent damage to installed fire protect. Sorry. Elaborate. I repeat again because it's interesting. A nail, all nail and thigh holes, all cut, torn, and seriously abraded areas and lining shall be patched as follows. Patches made entirely with welding strip to be fused to line over entire patch area. Largest patches may consist of smooth liner sheet applied over damaged area with adhesive. All edges must be covered with welding strip fused to patch and sound lining adjoining damaged area. Hearth joint compounds such as coal tar shall not be poured or lining from equipment and materials taken through work. Testing requirement. Testing requirement. Okay. Testing requirement is samples taken from sheets, joints, or weld strips shall be tested to determine material properties. Determination of tensile strength and elongation shall be done in accordance with ASTM D412 using die B. Determination of indentation hardness shall be in accordance with ASTM D412 using die B. Determination of indentation shall be in accordance with ASTM D2240 using a type D 0 meter, except that a single thickness of material and indentation at this hardness shall be made on 25 mm by 75 mm specimen. 75 mm specimen. Thickness of specimen shall be thickness of sheet of strip. Determination of indentation hardness shall be in accordance with ASTM D240 using a type D 0 meter, except that a single thickness of material and indentation hardness shall be made with 25 mm by 75 mm specimen. Thickness of specimen shall be thickness of sheet or strip. Measurement of initial physical properties for tensile strength, weight, elongation, and indentation hardness shall be determined before chemical resistance starts. So you can say determination of indentation hardness shall be in accordance with ASTM D2240 using a type D 0 meter, except that single thickness of material single thickness of materials measurement of initial physical properties for tensile strength, weight, elongation, and indentation hardness shall be determined before chemical resistance tests. Measurement of initial physical properties of tensile strength, weight, elongation, and indentation hardness shall be determined before chemical resistance tests. Chemical resistance tests shall be carried out to determine physical properties of of specimen after exposure to chemical solutions. Test specimen. This, uh, Measurement of initial physical properties for tensile strength, weight, elongation and indentation hardness shall be determined before chemical resistance tests. Chemical resistance tests shall be carried out to determine physical properties of specimen after exposure to chemical solutions. Test specimen shall be conditioned to constant weight of 43 degrees at 43 degrees Celsius before and after submersion in solutions detailed in table for a period of 112 days at 25 plus minus 3 degrees Celsius. Chemical resistance tests shall be carried out to determine physical properties of specimen after exposure to chemical solutions. Test specimen shall be conditioned to constant weight at 43 degrees Celsius before and after submersion in solutions as described herein for a period of 112 days. Volumetric percentages. Page 152 it is. Let us see where we left something there. Okay, now we left something here also. Let us go there. We were here actually testing and repairing damaged surfaces. I think we missed something here, yes. We missed something here, and let's go there as well. And this is so we got here volumetric percentages of concentrated reagents. Volumetric percentages of concentrated reagents of CP grade at 28-day interval. Specimen shall be removed from each chemical solution and tested. If specimen fails to, if any specification fails to volumetric percentages of concentrated reagents of CP grade at 28 days intervals, specimen shall be removed from each chemical solution and tested. If specimen for heavy, because any specimen fails to meet 112 days exposure, material will be subject to rejection. It says volumetric percentages of concentrated reagents of CP grade on 28 days intervals. At 28 days intervals, where specimen shall be removed from each chemical solution and tested. If a specimen fails to meet 112 day extension. We say pull test concrete. I'm sorry. Pull test for locking extension. Liner locking extensions embedded in concrete shall withstand a test pull of at least 18 kilonewton per meter. Liner locking extension embedded in concrete shall withstand a test pull at least 160 degree. Says what we say, pull test for locking extension, liner locking extensions embedded in concrete shall withstand a test pull of at least 18 kilonewton per meter applied perpendicularly to concrete surface for a period of 1 minute without rupture of locking extension of withdrawal from embedment we can say without rupture of locking extension or withdrawal from embedment. This test shall be made at temperature between this test of this shall be made at temperature between 21 to 27 degrees Celsius. These are very technical points. We have to just keep in mind that this is not very ordinary work, very much technical work. It says again, IA says withdrawal from embedment. This test shall be made at a temperature between 21 to 27 degrees Celsius, generally air conditioned temperature. Sharp weld joints. Sharp weld joints. Sharp weld joints used to fuse individual section Sharp weld joints used to fuse in individual sections of liner together. Sharp weld joints used to fuse individual sections of liner together shall be at least equal to minimum requirements of liner for thickness, corrosion resistance and impermeability. Weld shall show no cracks or separations and be tested for tensile strength. Tensile strength measured across welded joints. Tensile strength measured across welded joints in accordance with the STM D1412 using dia B shall be at least 1.5. That's what's happening now, like calls, I don't know. Somebody calling, somebody not calling, what do you want to do? I'm interested in something else, that's what it is. And it is there, I don't know why people interfere with this. What they get. What's there? What? Speak up. Speak up. Why don't you speak? बोलते क्यों नहीं भाई? नहीं बोलना तो कॉल क्यों कर रहे हो? अरे बोलना भी नहीं है, क्या करेंगे भाई कॉल करके? Just calling for nothing. What to do? What's there? Nothing. Yeah, my God, these people waste time. So I am disturbed by these people for nothing. Disturb for nothing, Disturb for nothing. Sharp welded joints I was talking of, and disturbed. So sharp welded joints used to fuse individual sections of liner together shall be at least equal to minimum requirements of liner for thickness, corrosion resistance and impermeability. Weld shall show no cracks or separations. Shall be tested for tensile strength. Tensile strength measured across welded joints in accordance with the STM D412 using die T. Die B shall be at least 15 MPa. Test temperature shall be 25 plus minus 3 degrees Celsius and measured minimum with all lines shall be sharp tested for holes with a spark tester set to provide from 15,000 to 12,000 20,000 volts. All liner shall be sharp tested for holes with a spark tester set to provide from 15,000 to 20,000 volt. Shields having holes shall be satisfactorily repaired in shop before shipment from manufacturer plant. Contractor shall provide the engineer with certified copies of test reports before shipment of product is done to site. What's that? Criticality, chemical resistance test. Now see what's that? Chemical resistance test. Sulfuric acid 20% concentration 20%. That is chemical resistance test. Sulfuric acid is 20%. Sodium hydroxide 5%, ammonium hydroxide 5%, nitric acid 1%, ferric chloride 1%, soap 0.1%, detergent linearly alkyd 1, benzyl sulfonate or LAS, that is linyl alkyl sulfonate 0.1%. Bacteriological biochemical oxygen demand not less than 700 milligram per liter. Phosphoric acid 50%. This is chemical resistance. That's a very important one. Sulfuric acid 20%. So this sulfuric acid 20%, sodium hydroxide 5%, ammonium hydroxide 5%, nitric acid 1%, ferric chloride 1%, soap 0.1%, and detergent liner alkyl bronzyl ferrous 0.1%, bacteriological BOD not less than 700 milligram per liter, and phosphoric acid 50%. Special requirement. Sheet to be closely fitted and properly secured to inner forms. Sheets that are to be cut to fit curved and warped surfaces shall use a minimum number of separate pieces. A 50 mm wide water resistant tape or welding strip shall be welded on back of butt joints to prevent wet concrete from flowing around edges. liner sheets to be closely fitted and properly secured to inner forms. Sheets that are to be cut to fit curved and work surfaces shall use a minimum number of separate pieces. A 50 mm wider water resistant tape, a 50 mm wide water resistant tape or welding strip shall be welded on back of butt joint to prevent wet concrete from flowing around edges. Unless otherwise shown on drawing, lining will be returned at least 75 mm at surface of contact between concrete structure and can say and unless otherwise shown on drawing, lining will be returned at least 75 mm at surface of contact between concrete structure and items not of concrete element. Now say, unless otherwise shown on drawing, lining will be returned at least 75 mm at surface of contact between concrete structure and item not of concrete element. Same procedure shall be followed at joints where type of protective lining is changed or new work is built to join existing unfined. At each return, the return line will be sealed to item in contact with plastic lined concrete with an adhesive system. If liner cannot be sealed with this adhesive because of joint in return being too wide or an inch or rough, or because of safety regulations, joint space shall be densely caulked with lead wool. And liner liner cannot be sealed with this adhesive because of joint at return being too wide or rough, or because of safety regulations. Joint space shall be densely caulked with lead, wool, or other approved caulking material to a depth of 50 mm and finish with a minimum 25 micron 25 mm. Okay. Now, joints in lining for in situ concrete structures. I'll be again, if liner cannot be sealed with adhesive because of joint at return being too wide or rough, or because of safety regulations, joint space shall be densely caulked with lead wool or other approved caulking material to a depth of 50 mm and finished with a minimum of 25 mm approved corrosion resistance material. Joints and lining for in situ concrete. Field joints and lining at joints shall be free of all mortar and other foreign material and be clean and dry before joints are made. All welding is to be in strict conformance with specifications of lining manufacturer. So now we come to joints in lining for institute concrete structures. Field joints and lining at joints shall be free of all mortar and other foreign material and shall be clean and dry before joints are made. All welding is to be in strict conformance with specifications of lining manufacturer. Testing and repairing damaged surfaces. All surfaces covered with lining, including welds, shall be tested with an approved electrical holiday detector with instrument set at 9000 volt per 1 millimeter of lining minimum. Field joints and lining for institute concrete we are talking, and this is testing and repairing damaged surface. Testing and repairing damaged surfaces. And it says all surfaces covered with lining, including welds, shall be tested with an approved electrical holiday detector with instrument set to 9000 volts per 1 millimeter lining minimum. Weld shall be physically tested. Weld shall be physically tested by a non-destructive probing method. All patches, overhauls or repairs to liner wherever damage has occurred. Since all welds shall be physically tested by a non-destructive probing method, all patches, overhauls or repairs to liner wherever damage has occurred. Each transverse weld welding strip which extends to lower edge of liner will be tested by an approved test agency or so this is here. This is testing and repairing damaged surfaces. Once again, all surfaces covered with lining, including welds, shall be tested with an approved electrical holiday detector with instrument set to 9000 volt per 1 millimeter of lining minimum. All welds shall be physically tested by a non-destructive probing method. All patches over holes or repairs to be to liner wherever damage has occurred. Each transverse welding strip which extends to lower edge of liner be tested by an approved testing agency at cost of contractor. Welding strips shall extend 50 mm below liner to provide a tab. A 5 kilogram pull A 5 kilogram pull shall be applied to each tab. Force shall be applied normal to face of structure. It says this 5 kilogram pull shall be applied to each tab. Force shall be applied normal to face of structure by means of a spring balance. Spring balance. Liner adjoining welding strip shall be held against concrete during application of force. 5 kilogram pull shall be maintained if a weld failure develops until no further separation occurs. Defective welds shall be retested after repairs have been made. Tabs shall be trimmed away neatly by installer of liner after welding step has passed inspection. Inspection will be made within 2 days after joints have been completed in order to prevent tearing, projection. Now, go further. It is if 5 kg will be maintained if a valve failure develops until no further separation occurs, defective weld shall be retested after repairs have been made. Taps shall be trimmed away neatly by installer of line after welding strip has passed inspection. Taps shall be trimmed away neatly by installer of liner after welding strip has passed inspection. Inspection be made within 2 days after joints have been completed in order to prevent tearing projection weld strip and consequential damage to liner from equipment and material used in or taken through work. Very different topic of practical importance, very significant, because hot weather condition, in that condition concrete has to work. We have to think also how to improve this. Hot weather concreting, in this there is scope in general conditions, in general ways, that scope references definition of hot weather, system description, submittals, then placing temperature, planning concreting, mix design, and temperature controls in general, and you can say liquid nitrogen, then addition of ice and liquid nitrogen, batching and mixing and transportation, placing and finishing, curing and protection, inspection and testing. Hot weather concrete, important topic, very very important from many viewpoints. The development has been going in these nations where hot weather conditions do exist. In our country as well, where generally hot weather exists for a couple of months, and in those months what we have to think about or do. So we can see this part covers precautions to be taken for hot weather concreting for all structural concrete except blinding one, where a minimum compressive strength is specified. Blinding is not to be worried about. There is relation to Part 6 property requirement, Part 7 concrete plants, Part 8 illumination weather. So we go forward on this. Let's say how to go up, and you can see you can say American Concrete Institute (ACI) hot weather concreting, measuring temperature concrete, and Eurocode 2 design of concrete structures, general rules and rules for buildings. That is Eurocode 2 design of concrete structures, general rules and rules for buildings, admixture for concrete, mortar and grout, test methods, and then admixture for concrete, mortar and grout. Definition of hot weather. What is weather? Definition of hot weather. It's requirements of hot weather. Requirements of following clauses. Requirements of following clauses of specification are applicable during hot weather period of Qatar. So we are talking of it can be anywhere. It can be wherever you can say, not necessarily Qatar, but here because the specification comes from Qatar, so that's the reason. And hot weather requirements of following clauses, specifications. I think some problem, So, definitions of hot weather here. Requirements of following clauses of specifications are applicable during hot weather period in Qatar. Hot weather period means you can say requirements of hot weather period defines as starting when maximum ambient air temperature on site exceeds 35 degrees Celsius for 3 consecutive days. Mind it. Analyze. Hot weather period shall be defined, as starting when temperature is 35 degrees, that is maximum ambient air temperature on site exceeds 35 degrees Celsius for 3 consecutive days. End of hot weather period shall be defined as period when maximum air temperature is below 35 degrees Celsius on 3 consecutive days. So above 35 degrees, therefore 3 days, consecutive days 1, 2, 3, and also below same 3 consecutive days. So 35 degrees for 3 days is, you can say, reference to understand about what is hot weather. Contractor establishes a thermometer. Contractor shall establish a thermometer on site that records ambient air temperature. Remember, we are talking of ambient air temperature, not direct sun, under shade. Contractor shall establish a thermometer on site that records an ambient air temperature. Thermometer shall be established at a position to provide representative air temperature for site conditions. If requested by engineer, contractor shall arrange for calibration of site thermometer. hot weather means combination of following conditions that tends to impair quality of freshly mixed or hardened concrete. Hot weather shall mean combination of following conditions, any combination, one combination, let's say, it tends to impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss and rate of cement hydration or otherwise causing detrimental results such as high ambient temperature when shade temperature is above 40 degrees Celsius on a rising thermometer and 43 degrees Celsius on falling thermometer, a high concrete temperature, low relative humidity, high wind speed. This is hot weather shall mean any combination of following conditions that tends to impair quality of freshly mixed or hardened concrete by accelerating rate of moisture loss and rate of cement hydration or otherwise causing detrimental results such that high ambient temperature when shade temperature is above 40 degrees Celsius or on a rising thermometer 43 degrees Celsius on a falling thermometer, high concrete temperature, low relative humidity, high wind speed. High wind speed. Kilogram per meter square per hour. Rate of evaporation exceeds 0.5 kilogram per meter square per hour. System description. System description. Contractor shall undertake hot weather concreting procedures that are effective in controlling following potential problems associated with concreting in hot weather. Contractor shall undertake hot weather concreting procedures that are effective in controlling following potential problems associated with concreting in hot weather. Increased water demand of mix. Increased water demand of mix. Increased rate of slump loss. Increased rate of setting. Increased tendency of plastic shrinkage cracking. Decreased long-term strength, increased tendency of drying shrinkage and cracking, increased tendency for differential thermal stresses, thermal effects with consequent cracking, decreased durability from cracking where there is increased permeability, decreased durability from cracking where there is decreased permeability. So these are very important points. System description. This is, let's say, what is that? Increased water demand. That is, contractors shall undertake hot weather concreting procedures that are effective in controlling following potential problems associated with concreting in hot weather. Problem C is number 1 in this list. as increase of water demand, increased water demand of mix, and you can say increased rate of slump loss, increased rate of slump loss, and you can say increased rate of setting, increased tendency for plastic shrinkage, cracking, decreased long-term strength, increased tendency for drying shrinkage and cracking, increased tendency for differential thermal effects with consequent cracking. You can say decreased durability from cracking where there is increased permeability. These were points which are very important when we discuss about these problems that deal one by them. Let's look at how to do that. Contractors shall prepare weekly in advance its proposed concreting program, showing quantities to be placed and anticipated placing hours. At least 1 month before start of hot weather period, contractor shall submit its specific proposals for control of concrete temperature, for constituent materials, cement, water, aggregate. Where required, contractor shall submit to engineer its proposals for use of liquid nitrogen for cooling, which shall include details of previous project application, and intended methods are to be used and quantities of liquid nitrogen. Says, again I read, contractors shall prepare weekly in advance proposals concerning program of concrete, showing quantities to be placed and anticipated placing hours. At least 1 month before start of hot weather period, contractors shall submit his specific proposals for control of concrete temperature for constituent materials, cement, water, aggregate. Where required, contractor shall submit to engineers its proposals for use of liquid nitrogen for cooling, which include details of previous project application and intended methods to be used and quantities of liquid nitrogen. Placing temperatures. This support of specification applies at all times of year and at all times of day. Maximum fresh concrete temperature at placement shall not exceed 32 degrees Celsius unless construction testing to verify a proposed concrete mixture functions satisfactorily at a concrete temperature greater than 32 degrees Celsius. No concrete shall be placed if concrete temperature exceeds 35 degrees. Concrete shall not be placed if shade temperature exceeds 40 degrees Celsius. Temperature of each truck of concrete shall be measured using either a glass, dial type or electronic thermometer just before placing of concrete and temperature recorded on daily ticket. Maximum temperature at placing shall apply to entire load of concrete in truck or conveyor. Give me a couple of minutes, please. Placing temperature, I'm back with that, okay, right? So we can say placing temperature. This is a part of specification, as I discussed before. It says that concrete temperature should not exceed 32 degrees Celsius. That's very important. And if you can prove that concrete is not harmed, it can rise up to 35 degrees. It says maximum fresh concrete temperature at placement shall not exceed 32 degrees Celsius, and this is for whole year, all times of day. And unless construction testing to verify a proposed concrete mixture will function satisfactorily at a concrete temperature greater than 32 degrees Celsius, no concrete shall be placed if concrete temperature is above 35 degrees Celsius. And if sheet temperature exceeds 40 degrees Celsius, no concrete shall be placed. Temperature of each truck of concrete to be measured using either a glass dial type or electronic thermometer just before placing of concrete, and temperature recorded on delivery ticket. Maximum temperature at placing shall apply to entire load of concrete in truck or conveyor. Increase in concrete temperature period from dispatch from plant while in transportation or whilst awaiting placement on site, and take adequate measures to ensure maximum temperature is not exceeded. Allowance for increase in temperature during dispatch from plant to transportation is completed has to be considered. Contractor shall allow for increase in concrete temperature in period from dispatch from plant while in transportation or whilst awaiting placement on site, and take adequate measures to ensure maximum temperature is not exceeded. Planning concreting. During hot weather period, as defined in clause of this part, during hot weather period as defined, contractor shall plan concreting operations such that no concreting happens, no concrete is placed between hours of, you can say, 10 hours to 17 hours. 10 hours in morning to 17, that's evening. Contractors shall arrange, this is time for Qatar, You can decide your run time wherever you are located, in which hours temperature remains below 40 and 35, so that concrete temperature at placement does not exceed 32 degrees Celsius and shade temperature does not exceed 35 to 40 degrees Celsius. Contractor shall arrange concrete pours such that program of works can be achieved without concreting during period from as described 10 hours to 17 hours. Contractor shall nominate one member of staff to be coordinator for supply of concrete. Coordinator's responsibilities include ensuring batched rate matches that of delivery and placement, of course preparations mix design. In hot weather period, contractors shall review all concrete mix designs to ensure the design slump or workability specified is achieved without increase in mixed water content. Contractors shall make modifications to mix design to allow for increased slump loss during transportation in hot weather. This shall be achieved by adjusting proportion of admixture. This shall be achieved by adjusting proportion of admixture, plasticizer or super plasticizer. Permitted range of admixture shall be clearly stated on concrete mix design with nominal values for cold weather and hot weather use. Under no circumstances shall addition of extra water that increases water cement ratio be permitted during hotter weather. All concrete materials and proportions used in periods of hot weather shall be those that have a satisfactory record of use in such conditions. Contractors specific proposals. Contractors specific proposals for control of concrete temperature shall include contractors specific proposals for control of concrete temperature shall include extent and type of shading of aggregates. Extent and type of shading of aggregates. Method of chilling mixed water. Method of chilling mixed water and procedures for batching and mixing. Transportation. placing and finishing, curing and protection. I repeat, contractors' specific proposals for control of temperature. Concrete temperature shall include extent and type of shading of aggregate, method of chilling mix water, and procedures for batching and mixing, transportation, placing and finishing, curing and protection. These shall include calculations in accordance with ACI 305R Clause 3.1, that is estimating concrete temperature. Contractor shall calculate temperature of freshly produced concrete based on input temperature of constituent materials and weights from particular mix design. Calculations shall make allowance for rise in temperature between mixing and placing due to transportation and waiting period. Calculations shall successfully demonstrate that temperature can be maintained below 32 degrees Celsius at point of placing. It says, contractor shall calculate temperature of freshly produced concrete based on input temperature of constituent materials and weights from particular mix designs. Calculation shall make allowance for rise in temperature between mixing and placing due to transportation and waiting period. Calculation shall successfully demonstrate that temperature can be maintained below 32 degrees Celsius at point of placing. Stockpiles of aggregate shall be shaded from direct sunlight. Stockpiles of aggregates shall be shaded from direct sunlight. Shade shall extend beyond edge of aggregate, storage areas and stockpiles layouts shall be such that direct sunlight is not incident on aggregates. Means you have to set layout accordingly. Shades shall be constructed to allow access for mechanical showers. Shades shall be constructed to allow access for mechanical showers or means of conveyance. Shades and stockpiles shall be constructed so as to permit free flow of air over aggregates. Embedded cooling pipes may also be used to cool aggregate. Sprinkling of coarse aggregate to reduce temperature. Sprinkling coarse aggregate to reduce temperature by evaporation or direct cooling shall not be permitted. Sprinkling of coarse aggregate to reduce temperature by evaporation or direct cooling shall not be permitted. Underground tanks are insulated above ground. Water shall be chilled by use of proprietary chillers or addition of ice to water tank. Measures shall be taken to ensure that ice pieces are not inadvertently deposited directly into mixer. Water shall not be chilled below a temperature of 5 degrees Celsius. Water shall not be chilled below a temperature of 5 degrees Celsius. Tanks, pipes or trucks used for storage of transportation of water. Storage or transportation of water shall be insulated and painted white. Mechanical refrigeration equipment and insulated water. Mechanical refrigeration equipment and insulated water storage shall be adequate for anticipated hourly and daily production rate of concrete during hot weather period. Mechanical refrigeration equipment and insulated water storage shall be adequate for anticipated hourly and daily production rates of concrete during hot weather period. Mixing water may also be chilled by injection of liquid nitrogen. Mixing water may also be chilled by injection of into an insulated holding tank. Mixed water may also be chilled by injection of liquid nitrogen into an insulated holding tank. Such procedures shall be to approval of engineer. Ice shall be completely melted in mixing water prior to adding water to mixer. Cement. Use of freshly ground cement at very high temperature is not permitted. Use of freshly ground cement at high temperature is not permitted. Cement shall be kept below temperature which there is a tendency of false set. Cement shall be kept below temperature which there is a tendency of false set. Under no conditions shall temperature of cement exceed 75 degrees Celsius. Under no conditions shall temperature of cement exceed 75 degrees Celsius when it enters mixture. 75, it should be below 75 degrees Celsius. Under no conditions shall temperature of cement exceed 75 degrees Celsius when it enters mixture. Under no condition shall temperature of cement exceed 75 degrees Celsius. I am repeating it, when it enters mixture. Contractor shall make arrangements. Contractor shall make arrangements, contractors shall make arrangements for storage on site to allow cooling of freshly ground and delivered cement. Addition of ice. Crushed, shaved or chipped ice. Crushed, shaved or chipped ice can be used as part of mixing water for reducing concrete temperature. Crushed, shaved or chipped ice can be used as part of mixing water for reducing concrete temperature. Maximum nominal size of ice particles shall be 10 mm, and all ice must be melted before completion of mixing of concrete in pan. To ensure proper concrete mixing, maximum proportion by substitution shall be 75% of batch water requirement. To ensure proper concrete mixing, maximum proportion of substitution shall be 75% of batch water requirement. Crushed ice shall be stored at a temperature that prevents lumps from forming by refreezing of particles. Says crushed ice. Crushed ice shall be stored. Crushed ice shall be stored at a temperature that prevents lumps from forming by refreezing of particles. Batching plant shall incorporate. Batching plant shall incorporate a mechanical system for correctly proportioning and weighing ice to be added to mixture. Quantity of ice shall be deducted from total batch water. Contractor shall ensure there are adequate quantities of ice in suitable refrigerated storage on site at plant to meet anticipated daily and hourly production rates of concrete during hot weather period. Contractor shall ensure there are adequate quantities of ice in suitable refrigerated storage on site at plant to meet anticipated daily and hourly production rates of concrete during hot weather period. Liquid nitrogen. Freshly mixed concrete may be cooled by injection of liquid nitrogen. Freshly mixed concrete may be cooled by injection of liquid nitrogen. Care shall be taken to ensure that concrete delivery adjacent injection nozzle is not frozen. Care shall be taken to ensure that concrete directly adjacent to injection nozzle is not frozen. Freshly mixed concrete may be cooled by injection of liquid nitrogen. Care shall be taken to ensure that concrete directly adjacent injection nozzle is not frozen. Use of liquid nitrogen for cooling concrete shall include a nitrogen supply vessel and injection facility for batching plant or one or more injection station for truck mixer. Use of liquid nitrogen for cooling concrete shall include a nitrogen supply vessel and injection facility for batching plant or one or more injection stations for truck mixers. System may be set up at site for injection just before placing. Proper safety precautions is advised by supplier of liquid nitrogen shall be used. Batching and mixing. It's interesting, really getting interesting day by day, particularly this time when we are talking of controls of mixing, controls of concrete. Interesting one, I think it should be valued. We're talking batching and mixing. Drums of concrete mixer truck, drums of concrete mixer trucks shall be painted white to minimize solar heat gain. Where a truck mixer has been left standing in sun, empty drum shall be sprayed with water and drum flushed out with cold water before batching. Care shall be taken to ensure all water is removed from drum before batching. Temperature of concrete shall be checked after discharge from mixture and written on delivery ticket. Temperature of concrete shall be checked after discharge from mixer and written on delivery ticket. Temperature check shall be carried out at plant on concrete floor for every 50 meter cube. Temperature check shall be carried out at plant on concrete floor for every 50 meter cube. Produce or every hour, whichever is minimum. Water reducing, set retarding chemical mixture. Water reducing, set retarding chemical mixture conforming to requirement of BSEM for 80 parts 1, 2 and 4 may be used in varying proportions under different air temperature conditions. This is batching and mixing, and we will take up later on. Because already is time and we did this today. I have done this interestingly, and I remind you about this also. This one, certification, and how we have to be careful about quality issues. That is important point, and that's why I'm trying to disseminate this information for this purpose alone. And I think we should be careful about this. If we can do something on this, we should do. If we can do something in this interest, in our interest, in national interest, in international interest, both, we have to do something here. That's very, very important. If we can do here, fine. Shall we okay? That's what I say. And with this, I think I have to take a closer of this. In this regard, I take your leave now. I think that's enough.